It's now confirmed that coming to office hours saves you 50% of
my work.
Nice. Okay, yeah. So I guess just mention that to people. If you're looking at the 2018 version, it's the same except that you have to do exercise 11.4 and 11.5. You only need to do exercise 11.4. The 2019 version only stars exercise 11.4. Somebody's gonna turn in both.
Yeah.
Despite best efforts. Okay, so this Wazowski derivative thing.
Mm-hmm.
So, okay. I guess we can start at the...
Example?
Which example do you want to look at? Example 11.3? I think that's a little too late to start. I think we should go to just where DA is defined.
Okay.
A little higher up. Just under 11.1.
Sure.
So, why is this interesting? Like, why do we even care about this? Like, the definition makes sense, right? It's that dA of L is the language of every string such that
String starts with A.
such that the string starts with A and it's in the language L, right? Why is that interesting? And why is it on so the big thing to think about is the characters on the left side, and that's really important.
Mm-hmm.
Why is that important? Think about DFAs and what DFAs do.
DFAs move left to right.
Yeah.
That's why.
Yep.
Okay.
So it's got this similar feel to a machine.
Mm-hmm. I see. So you can just do derivatives step by step until you reach the end.
Basically. So now this example should make significantly more sense.
Yeah.
Right? Because
Oh, okay. All right.
sorry, this sound's gonna be awful. I forgot to move this. I was sitting right over there, so it should actually be decent for the beginning of the video. Okay, so what is this like Frankenstein monster of a machine? I'm actually probably just gonna sit over here most of the time, so maybe I should just drag this.
Okay.
This should help us make a lot more sense.
So 0, 0 plus 1, 1 star 0, 1 plus 0, 0.
I mean, you can just look at. He has the picture for you. So.
Oh, okay. I see what you're saying.
Okay, so this first, in this first state, let's see.
If you have a 0 to start, you move to the next step.
Yes.
Okay, which is you pull out a 0 from the initial expression, because you know it starts with 0 anyway.
Mm-hmm.
I don't understand the second part. What is the second part doing?
The second part is, so these first two are considering what happens, the strings that start with 0 that are in the language.
Okay.
And the strings that start with 1 that are in the language.
Okay.
And it's trying to simplify those in some sense, right? Because we'll see. Note that here that recognizing whether state order is equivalent to asking whether, which is equivalent to asking, what is delta R again?
Isn't R the thing
so
that
we
pull
need
out?
to go to this, or is it that delta?
Oh, delta R?
Is it, what symbol is this? Sigma? I can't remember. Is that little delta?
I think that's delta, yeah.
Okay, I think it's a little delta. Right, so it's saying that empty string is in R or empty string is not in R.
Mm-hmm.
That's all it's testing. So whether or not a state R in the diagram above is final is equivalent to asking whether epsilon is in R. Okay. So, if we're looking at a string, right. So, once we go to the next four are actually all important. But let's just focus on the next two. So the third and fourth bullet point. What those are essentially looking at is notice the state they're operating on, like the string you're applying d sub 0 and d sub 1 to, is equivalent to, I think it's the top state.
The first string, yeah.
It's equivalent to this top one in the DFA. Let's look at the DFA though, right? So yeah, it's equivalent to the first output from D0 of the starting spot.
I'm kind of confused about, like, so you remove a 0, but then what is that plus 1, 0, 0, plus 1, 1 star at the end?
Right, all of that just comes from the rules between 11.1 and 11.2. You're literally just following these rules. Because these rules will tell you
Oh, I see. It's delta R dA of S.
Yes.
And
delta and dA are both important because you need delta in part of dA.
In this case, S is 0, 0 plus 1, 1.
In this case, S
star
is 0, 0 plus 1. Wait, where is it?
Delta A of RS equals delta.
Yes.
Yeah, but in this case, in the first line of example 11.3,
yes.
S in this example is 0, 0 plus 1, 1. So delta R.
It's the 0, 0 plus 1, 1 star.
Yeah.
Yes, it's that, but you have to apply it twice, right? Because then the thing you just applied, the thing that's R, is also concatenation, and so the D of R you're gonna have to apply this rule a second time, right? The calculations in 11.3 are like non-trivial and a pain.
Why is D A? What is delta R here?
So delta R is pretty simple. It's actually just the empty string if the empty string is in R, is in the language of R, and it's the empty set otherwise.
Okay.
Yeah.
So dA of S in this case is 1 times, or I guess.
So it is the empty set, right? Because delta of R is non-empty. Wait, does it accept the empty string? No, delta R doesn't accept the empty string because it's 0, 1 plus 1, 0.
Okay.
It means that it won't accept the empty string, which means that the empty string's not in the language, and so delta of R is empty set.
So delta of R is the empty set. Okay,
yeah.
So delta of R is the empty set. And then dA of S is if you
okay, let me just write down the
A.
first. Let's just do the first one on the board.
Sure.
It's the very first one. D0 of terrible essay. Just don't wear my glasses. What is it? 0. Is that right?
Yeah.
Okay. So I can split this into so let's call this R. I'm gonna switch markers because this is a piece of crap. You need to just stand up for a couple minutes. Actually, hard to do that here. There we go. That's a good eraser. Here it is. Like this.
The empty string is only accepted if the final state is the first state, right?
What?
the empty string is only accepted if the final state is the first state.
The empty string is only accepted if yes.
Okay.
Yeah. In NDFAs, you could have like epsilon transitions.
Okay, yeah,
Right.
I forgot about that. Yeah.
So it's a little model. It's model dependent.
Okay.
But in DFAs, yeah. Let's see. So. Okay, so what's the rule for DRS? I should say.
Derivative A with respect to R times S.
Is.
That's the first part.
Oh, right.
And then
So it's derivative of what?
0, D0
D0
of R
Yep. I don't know. It's here. Just read it off to
times
me.
S
Times S.
plus delta R times D0 of S, yeah.
Okay, so that's empty set. D0 of R is going to be complicated. So how does empty set interact with D0S here? He has a comment on it. Note here how product of DRS is the effect of R, letting R control whether or not S participates. That's true. Right. So it's empty set.
It's just, yeah.
It's just all of this is empty set. That's what I thought. I just want to double check because I've never seen these things before. So cool. This goes away. Actually, I shouldn't erase it. I should just cross it out.
Empty
so this
set.
equals
Okay.
empty set. Just cross all this out.
When would it be the empty string?
When this accepts the empty string.
When this accepts it. Okay.
Oh no! Wait. Sorry. Yeah. R doesn't accept the empty string because of this. So.
Yes. Okay. Well. Okay. Would it if it was 0, 0 plus 1, 1 star?
Then yes, because star can be 0. Like star can be this 0 times.
Oh, okay.
So.
Yeah, I forgot about
The
that.
shortest strings that you can accept it because of this is 0, 1, and 1, 0.
Got it.
But if this was star, you could accept the empty string.
that's just-
Okay,
there has
so
to
now
be
we're down
one
to
of them.
D0 S, so let's apply the rule again, making this R this time. And this S. Nobody's ever going to be able to read that from the screen, but whatever. They heard me say it, so hopefully it'll be good enough. Let's see. So we're going to take D0 this time. I'm actually just going to explicitly write it, and I'm going to write bigger.
Well, you keep the S, right? So isn't it just the same thing as before?
No. R is this, and S is this now.
Why?
It's the same equation, but on different objects. So first I was taking D0 of the whole thing.
Yes.
So I needed to use dr concatenated with S rule.
Okay.
I called these two first parentheses R, and I called this one S.
Okay.
Right? Then I applied the rule. This goes away.
Okay.
Now I have D0 of R, which is only these two,
Okay.
concatenated with S.
Oh, just with S on its own.
Yeah.
Oh, I see.
S
I see.
concatenated. So we have
No, we do
D0 of
plus 1, 1 star.
0, 0 plus 1, 1 star, exactly.
So you take this to be R.
And then you have concatenated with 0, 1 plus 1.
Well,
0.
again, doesn't it cancel out?
No, this is not.
Oh no,
This
because
is
R
here.
is good.
So it will yeah, R will not
So
cancel
that
it out. So it's
D0 RS
plus delta of R, which I'm not going to write again. 'cause
which
I'm
is just
lazy,
the empty string, right?
which is just the empty string. So we cross this
So
out, but
that
not the
can
rest.
go away. Got it. Okay.
So we have D0
S.
of 0, 1 plus 1, 0. Yeah, this is like that example 11.13 is hella long.
Yeah.
To like actually write it out. Yeah. It looks small, like not. It already looks kind of big, and then you actually do the math, and you're like, oh my god, this
Yeah.
is a nightmare. I think your homework exercise is a little easier. It's similar. It's gonna be long, but it's gonna be easy. Like it's gonna be easy isn't the right word. It's gonna be long, but it's gonna be procedural. It's not gonna really require
As many. Okay.
Yeah.
Oh my God! So now it's this whole thing times s,
So you get the idea now,
and then
right?
you just keep going.
Yeah.
Until you've simplified everything.
Yeah.
Okay, and then
So let's get some intuition though
how do you draw
as to
the thing?
why this is all interesting.
Okay.
So let's relate it back to the DFA that there's a picture of. Just under that DFA, notice he says that a state is an accept state if and only if the contained language accepts the empty string.
Okay.
Let's get at least some basic intuition. So
One state is an accepting state.
if and only if
and only
the
if.
language contained in the state, like notice how each state contains a regular expression.
Got it.
If the expression in there accepts the empty string, it's an accept state.
Oh, so that just means it's just done, right?
So
If you do
what's
an
the,
empty
what's the
string,
reasoning? The
so if
reasoning.
you do an empty string at that point in time, then we're finished. Is that what that means?
Yes,
Yeah.
but why?
Because there's nothing else to do.
So like if I take like 0, 0 plus 1, 1 star as my language in the first place.
Yeah.
Notice the first state of my DFA is the regular expression I'm starting with, right? And then my first state's an accept state because it's associated with this, which makes sense because this does accept the empty string. Basically, what this whole process is doing, it's simplifying the language at every step, and like at the first step for this, you don't want it to be an accept state because this regular expression doesn't accept the empty string. So as an input, like without any simplifications, you shouldn't be accepting. When I this whole process, the way it ends up working is you're in an your accept state is, what's the best way to put this? You can think about a DFA as like kind of like working left to right and like just eating the things on the string, right? And just like going through them like 0, 0, 1, like reads this is gone, reads this is gone. This is kind of doing that but on the regular expression. It's looking at some stuff and it's simplifying it. And it's looking at some stuff and it's simplifying it. Somebody else. We keep like cranking next to me. So it's kind of doing the same thing but on regular expression, simplifying it, and if at any point it accepts the empty string, if at any point the regular expression that's left accepts the empty string, then you've like chewed through enough of it.
So this is doing it without visibly showing a machine, like it's using derivations.
Yes.
Okay. So what do you do? How do you draw this?
So how you draw it is actually super easy once you have the equation.
Yeah, it looks like it.
Very procedural. So the states are the regular expression. So the first state is the regular expression you start with.
Then you do, oh my god, you have to do the derivation of 0 and 1 for every single thing.
So if you do,
Oh my
yes.
god, that's why this.
So it
takes
can
so long.
blow up exponentially. That's why I was like, oh geez. It shouldn't happen because
Okay, good.
he's
We
thought
only
about
have
this.
0 and 1.
So
At
you
least
do
for
D0. So you do D0 and D1 of your first regular expression,
Okay.
and that tells you D0 tells you where you should draw your 0 transition from
That
Your-
specific state.
from that state exactly.
Okay, so the second thing we did, we simplified to D0RS,
Yeah.
right? So that's where 0 would lead us, right?
Yes, I mean you have to compute it down to the end,
And then
right? You have to figure all of this out,
okay, yeah. Once you solve that, you
which
get this
comes out
term.
to this huge thing in the first line on the right side of the equal sign on the.
And that's what that is, right?
It'll eventually come out to that, yeah, if you keep computing.
If you keep computing it.
Yeah.
Okay. And then you do 0 to that again, and you keep doing that, and that would tell you where a 0 would lead you. But
Yes.
it turns out that 0 just leads you back to
That's
the
correct.
first state.
If you do D0 on
this.
your regular expression and then do it again on D0 of the starting regular expression is itself.
Okay.
It happens to cancel. That's not always the case. Yeah, so it's really easy to draw the machine once you've done all the work. But hopefully this gives you some intuition as to why it works. I mean, to really understand it, you need to read all of these simplification rules and go through each of them and convince yourself that they make sense, right? And that they mimic what the actions of like the DFA kind of should be doing.
So I have a question.
Yeah,
So D0 of 0, 0 plus 1, 1 star. I think this is like the middle line here. It's like the small line.
Where is it?
It's the first short line. There you
Okay,
go.
yep.
Right there.
Got it.
So that line, what's happening
Line
is you're
7.
applying the rule DAR plus S, and you're getting DA of R plus DA of S. Is that right? Because I don't really know
Yeah,
what to
so
do with
okay,
the star.
so
Oh no, it's the last rule. It's the last rule.
it's DR yes, it's the last rule. Wait, no. It's not the last rule, is it?
Yeah, it is. So you remove 0, 0 plus 1, 1, and then you do DA of 0, 0 plus 1, 1. Or D0.
So this is just you can only apply this rule when you have a regular expression star. But that's not what we have. It's the third short line is that rule. Right? We can apply that rule there.
Well, isn't R
So
0, 0 plus 1, 1?
line 7, which is the first short line,
Yes.
is still DARS. It's still that rule.
Why?
Because you have a concatenation. You have 0 concatenated with some parentheses in stars. The last rule can only be applied to DA of R star for some just like actually. You will have to use that rule because DRS will demand that you compute
Oh my god.
D0 of RS
Okay.
will demand that you compute D0 of R and D0 of S. R will be 0.
Okay.
S will be everything in the star. So D0 of S will be everything in the star value. That's when you will need the last rule
For the DA of
for
S.
the D0
Of S.
of the
S,
of S,
which is 0,
yes.
0 plus 1, 1
Yes.
star. Okay.
And so notice what happens here is that you then only need to compute D0 of itself once, of 0, 0 plus 1, 1, which is empty set. So it cancels the thing after it.
Yeah, that makes sense.
Because it
Because it
doesn't
starts
accept
with 0,
doesn't
right?
accept the empty string. Well, because the important thing is that
If it starts with 1, it becomes the empty string. Right.
sorry, what? Okay.
Yeah, see, like, the two steps which gives you empty set, they're both doing D1 of 0 and D0 of 1, but you can't do that, so you get empty.
D1 of 0 and D0 of 1.
Yeah.
So here's what I was trying to say. D0 of this equals empty set. Do you see why that's true? This comes from the last rule.
Okay.
Sorry, I should do. It's actually this.
This comes from the last rule. Okay.
Comes from the last rule because the last rule says that D0 of R star for some R is equal to D0 of R.
R star.
And then R star. But D0 of just this without star doesn't accept empty string.
Yes. Oh, yeah. Is that right?
So we have D0, let's see, D0 of just R is going to be some regular expression.
D1 does. D1 doesn't either.
DB equals F for B in the alphabet such that B doesn't equal A. Wait, what does that part say? Equals. So dr is those things plus each other. So it becomes this. It's more steps than I thought, but it's the same answer. I'm gonna just stop thinking about this because this part doesn't end up mattering. Okay. Technically, you have to bring it along for the ride at the end of everything, but just ignore it.
Wow, you really have to simplify this far.
Yeah, you do. It's
Wow.
There's a lot of steps in each of these steps.
So the first one is fine, right? D0 of 0, 0. Isn't that?
This one's fine, and this one's not.
Yeah.
One of them will equal empty set.
Well, D of 0 of 1, 1 is going to be empty set.
Right. And then the other one will be
That's by the third
string.
Rosowski rule. DA/B equals empty set
Yeah.
for B not equal to A.
That's what I believe.
But
that's what I
DA
thought.
of A equals the empty string,
But
right?
right now we have a concatenation.
Oh. Oh my god, are you
So-
kidding me? So you cancel out the D of 1, 1, right?
Yep.
Because we know that one's going to go
this
to
is
empty
gone.
set. That one is going to become D0
Technically,
of
this gets
0.
carried along for the ride. Right.
D0 of 0.
D0 of 0 is a concatenation.
And then 0 again. So 0, D0 of 0,
Here, let me just.
plus, oh my god, this is dumb. I don't like this.
I don't really like it either. Sorry, Stuart. There's a lot of writing.
D0, 0.
No. D0. So this is R and S.
Just D0.
Just D0.
And then 0.
D0 of 0, and then concatenate.
And then
with 0.
concatenate with 0. Plus delta of 0. R is 0, yeah. So delta of 0, which is...
Empty set, so it's gonna cancel everything over here. There's dot, but it's all canceled, right? Because this doesn't accept empty string.
Yes. Okay.
So
And
now
then
we have.
delta A of S, which is 0, so D0 of 0. Oh, that cancels everything. Okay.
So then we have D0
You
of
just
0,
get 0.
which is empty string, right?
Yes, so you just get 0.
So then we get 0. 0 concatenated with R star, right? Because R star should have come along for the ride this whole time. Like R star's still hovering out there.
Oh, and R star is 0, 0 plus 1, 1 star. That's where this comes from.
Okay.
Oh, that makes so
wait,
much sense.
This is D0 of this.
And then D0 of 0, 0 plus 1, 1.
Yeah. Okay.
Star is
so we
0,
just
0
we
plus
just
1, 1
did
star.
the first short line.
And then we're done.
Yeah. Wait, and then no. That just gets you to this step. It gets you to line 9. Look, it's D0 with R star is line 9. You still have to compute that actually gets you to this.
And then you have to use that last rule to get you back to...
You have to compute you have to do all the D0s and D1s until you stop getting new stuff. It's basically like how this is gonna work. Okay, the way to tell if you're not done, or the way to tell if you're done, is
I'm going to try
draw
to do
the
this,
DFA
this
while you-
one here, if
That's
that's
fine.
okay.
Yeah, that's fine. My best advice, do it step by step.
Yeah.
Like, do one state, do both
do-
transition rules.
Just do 0 first.
Just do, no. Do 0 and do 1 for the first state.
Okay.
Then, those arrows are going to be pointing places.
Yeah.
Then, pick one of them arbitrarily. Whenever you have arrows pointing at, here's the thing.
Then
every
look
state,
for that state's 0 and 1.
Yes, every state needs a
transitions.
transition rule for every alphabet character.
And there's 2 of them.
In this case, it's 2.
Yeah.
So, if a state does not yet have a transition for every character, you need to compute D of the missing character,
that makes so
missing
much
transition
That
character
makes a lot of sense.
for that state.
Okay.
Should be pretty easy to tell if you are done.
Okay.
Will it take a fair number, huge number of trees to compute?
Yeah, probably.
Yeah, a lot of
Okay.
paper.
Okay. I'm just gonna try this out.
No problem. I messed up this.